All right, so in this video, I'm going to solve some log equations for you that have multiple logarithms in them and look at the techniques involved in doing so. So here we go. So in our first one, we've got a fairly straightforward equation that looks like we'll need to use the quotient rule. If you recall, the quotient rule is going to be used whenever you have a minus in between your two logarithms. So we can put that together into a quotient. So we'll have log of r divided by 5 is going to be equal to 1. And then you want to remember that that is a log base 10, and we can read this using our sentence rule. So if you need to look back at the video on solving log equations like this by using the sentence rule, then feel free to do so. So I'm going to read this as 1 is the exponent on 10. That gives me r divided by 5. I would then just multiply by 5 on both sides, and we would be at our answer. R equals 50. And there we go. Let's look at another example. So on this one, we have both of these are logs base 36, so we can combine these together again using the quotient rule. We'll have log base 36 of v over 4 equals 1/2. Then I'd like to read this as my sentence rule like before. 1/2 is the exponent on 36. That gives me v over 4. So I'll pause here for a second and do 36 to the 1/2 power. Well, that's the square root of 36. So we have 6 equals v over 4, and we'll multiply by 4 on both sides. We get v equals 24. Now, before I start going too quickly, I want to make sure that I always do check that v equals 24 makes sense as a solution to the original equation. I can plug 24 in for v and see what happens, but I also just want to make sure that I'm never doing the log of a negative value, because that's going to come out undefined. So I always want to check that before I put a box around my answer and go too quickly. So let's look at this next one. Now, you might be tempted to subtract a logarithm on both sides and use that quotient rule again. But there's a much simpler way to go about a question like this with a logarithm on both sides. If the logarithm is the logarithm of the entire side in both cases, so notice we have log of 3z, that's the entire left side of the equation, and log of 2z plus 7 is the entire side of that equation. When that happens, you can just say, well, 3z must be the same as 2z plus 7, because if log of one of them is equal to log with the same base as the other, then those two things inside of the logarithms must be equal as well. So we can turn this into an equation that's pretty quick to solve. We just do some algebra and subtract 2z on both sides. We'll have 1z equals 7. And then, of course, as I said in the last example, we would check, but there are no issues with putting in that z is 7 on both sides of this equation for the z's. So let's jump right into example 4. In this example, we have a very similar situation, but this is natural log on both sides. And again, we have natural log of the entire side here is equal to natural log of the entire side over there. So these things inside must be equivalent. So negative 2y plus 4 must be equal to negative 3y minus 1. And the rest is algebra. So we're going to get all of the y's together over on the left side, and we'll get all of the numbers together over on the right side, and we end up with a total of 1y equals negative 5. Now, because I got a negative value especially, I'm going to want to check if negative 5 really works in this original equation. And when I put it into the equation, it does work out and everything is fine. All right, example number 5. Again, we have a situation with log of one side equals log of the other side. So these things inside of the logarithms must be equivalent. But now we've arrived just at a quadratic equation to solve. So I'm going to subtract 9 on both sides and get this set equal to 0. This equation will factor. So we have u minus 9 and u plus 1 is how this will factor. So we can say either u minus 9 has to equal 0 or u plus 1 equals 0, in which case one more step of algebra here. We get u equals 9 or u equals -1. Now, whenever this happens, it's really, really important to check your answers, because it can easily happen where one answer will work and the other answer will not work. In this example, both answers do check out. So I recommend that you check those to make sure that that is true. But in some examples, both answers will work, and in other examples, that doesn't necessarily happen. Let's look at example number 6. Here I have log base 5 on both sides, so I'm going to say the things inside of those log base 5s must be equivalent. And once you get used to solving these log equations, you do have to be careful that it really does fit the rule that you're used to using, because it's common that people will begin to work too quickly, and that's when we start to make mistakes. So after some algebra steps here, we should get y squared minus 9y plus 8 equals 0. And this will factor into y minus 8, y minus 1. Notice that they're both minus because we have -8 times -1 gets us this +8 that we want, and -8 plus -1 gets us the -9 that we want here. So if we jump to solving these two little equations, we get y equals 8 or y equals 1. Again, having two options here, very important that you check. If you'd like to pause the video and check, it's a good practice of putting 8 in for all of the y values up here on the top and really making sure that that's equivalent, and then going back through and putting in 1 for all of them and really making sure that it works out before you finalize your answer with a box around it. Now let's look at our last example. So this looks just like the previous examples, and you might be tempted to skip over this and to just move into your own questions to solve. But it's important that we look at this last example because it's really going to bring us to the epitome of what we've learned. So again, we have a logarithm base 10 on both sides. And so since that's the same base and it's the full side has been logarithmed base 10, we can just say that the insides would have to be equal to each other. So, I mean, this looks so much like what we had before. What could go wrong? Now, if we do a little bit of algebra here, we're going to add 3w, subtract 2 on both sides. We'll get everything over here together. We should get w squared minus 2w minus 15 is equal to 0. And this will factor again so that we have w minus 5 and w plus 3 should be how that factors. So w equals 5 or w equals -3. And you can be extremely tempted to just put a box around these and be done because it's the last one that we've done. But if I always remind myself to check my answers, what happens on this example is that one of them does not check out. One of them doesn't work. And so you want to be very careful about going through and just putting a box around your answers at the end. So it turns out that this answer does not check out, whereas this answer does work. And that can happen in these types of questions. So please make sure that you check. It doesn't mean that you did anything wrong for one of the answers not to check out. All right, I hope this helps. If you have any questions about this or any other topic, please just leave a comment down below.